what will the density of the radius of a sphere if is halved, compressing the air within? So it's asking density if radius of the sphere is halved. What would the sorry, what would it do? All right, so we have the density equation. So we know that D here equals mass over volume, right? Mass over volume. And we know that the volume of a sphere here is V equals 4 over 3 pi r cubed. And this you can find from a formula sheet or whatever you want. So what's saying is if the radius is halved here, how would that affect the density? So I'm going to substitute basically this volume equation into this density equation here. So I get a new equation. I would get D equals mass divided by 4 over 3 pi r cubed, or you could rewrite this as 3m equals 4 pi r cubed. And this here is our density equation. It's asking us what would the density of the radius, what would the density be if the radius of a square of a sphere is halved, right? So assuming that r here equals 1, our radius here is r equals 1, right? What if it was halved? I would get something like this. G would equal 3m over 4 pi. R would be half, and this is cubed, right? And we can solve for this. We can solve for, or we can rearrange this to see how it differs from our original equation here. So this here would equal 3m over 4 pi, and then 4 pi, and the half cubed would be 1/8, right? 1/8 here. And this would equal, again, 3m over 4 pi times 1/8 here, simply just 2. So this all equals simply just 2 pi, right? So this would happen to the density if it was halved here. And then if it was my original equation here, what would I get? I would get, if r here equals 1, 1 cubed is simply 1, right? So I would have 3m over 4 pi here. So this here just gets removed. So as you can see, my proportions here, if it was halved, if it was the normal radius, I would have 3m over 4 pi. If it was the halved radius, I would get 3m over 2 pi, right? So this is a difference of half here. So again, the density will be, if a sphere is halved, the density would also be halved here. So again, this solution, new density here is 3 times. Sorry, just give me a second here. I don't know why it says 3 times here. So V is, again, 4 pi over 3. So I don't know where the math went wrong here. Just give me a second. 0.5 cubed is 1/8 times. Oh, times 4 is half. Sorry, I messed up here. This is not 2. This is half here. This is half pi here. So it's comparing. I'm comparing these two guys here. Yes, this is correct now. So 3m here and half pi, 3m over 4 pi and half pi here. So I'm comparing half pi and 4 pi here. And as you can see, this is a difference of, if I basically ignore the numerators, because the numerators cancel out 3m and 3m here, I can set this as half pi here equals 4 pi. The pi's will also cancel out here, right? So half equals 4 here. So this, you can say what is the difference between this proportion here? I'm going to need, again, half times, I guess you can think of it as x or c or whatever you want. X here would have to equal 8 for us to satisfy this equation. So therefore, the density of a sphere would be 8 times the old density. So this solution here is correct. I messed up here and it said 4 times 8 is 2, whereas 4 times 8 is actually 1/2. So I forgot to include the half here. So this solution here is correct. Sorry about that. Good explanation.